Do you need help? About 200 DSG members. Gensco, we have 7 DSGs dedicated to Mitsubishi support. We have a lot of people backing up the product. Are you guys just now starting to get into VLM? You've been doing it for a while? You did Mitsubishi before? What's the primary product line?
Oh, Mitsubishi.
Mitsubishi? Mm-hmm. You tried any of the competitors?
Daikin.
Daikin?
LG.
How's that working out?
So far, so good.
That's good. I came from the Daikin side before I came to Gensco. They kind of stole me, and then, you know, they steal our guys. It's just revolving door sometimes.
Their manual's a lot better.
Their manuals?
Yeah, the Daikin.
I tried telling them.
Yeah, ours totally cold, no nothing.
Yeah.
On a Sunday.
They have some things that I liked, and I wish we did, and we have some things they don't do. So, wash us. Yep. You guys find Mitsubishi units or VRF in general is about this easy to install?
Yeah. It's about right.
Do you have problems when you install units?
Not really.
You hear about it afterwards. It really isn't that difficult if you've got the background or you know, the information. How many of you guys have actually been through a 3-day city multi-training class? 1, 2.
No,
Not a lot of them?
no, I guess not.
So you guys just read the manual when you get out there? Yep. That's what the #1 reason for a call to tech support is. Failure to read anything. So I'm going to skim through some of this equipment because it's really about installing, but I want to give you an overview of what you're going to be looking at out there. Right now we're on our K-Gen and L-Gen outdoor units from up to 336,000 BTUs on the L-Gen and 288 on the K-Gen, and we also have water source units. L-Gen now. The L-Gen outdoor unit is different than the K-Gen only in the fact that it has a micro-channel aluminum coil, which allows Mitsubishi to reduce the refrigerant requirement in the system by up to 40%. A big savings in refrigerant. We've also got hyperheat outdoor equipment. This equipment will do full heating capacity to 5 degrees. And it will continue heating down to about -20. A lot in Alaska. We've got our Y series, we call it. It's heat pump only. It does not do simultaneous heating and cooling. You might see this equipment in a big server room. Do 20 tons of cooling in a server room because all they want is cooling anyway, typically. You can connect up to 150% of the outdoor unit's capacity to this equipment. You need a minimum of 50% connected for it to run. If you have 49%, the unit won't start. So where's that great? One, if I got a diverse load, I can oversize my indoor equipment. You got to be careful. You got to have that diverse load for that to work properly. Because if you oversize it 30% and all the equipment's running at one time, all that equipment is derated 30%. If you got a situation where, and this happens a lot, I've got some cooling, critical cooling, I take the heat from the critical cooling room and I stick it into domestic hot water because we have heat exchangers that can do that. All right, Seth, what do you do?
Oh, sorry. I didn't know you guys could see that. The camera was stuck right here on that Gatorade bottle. And then there's 6 people saying, why am I looking at a Gatorade bottle? There you go.
We've also got our S-Series equipment. This is a single-phase city multi-unit. Even though the model number is PUMY, they were gonna call it, the model number was going to be a PUSY. Someone pointed out that might cause problems here in English-speaking countries. So we got the name S series, or the model number starting with a PUMY instead of PUSY. Single phase power up to 5 tons, but it's strictly a heat pump. No simultaneous heating and cooling allowed, or capable. And the branch box. You guys installed these, right? This is the magic box. This is something our competitors don't have. Everybody else uses a 3-pipe setup. You guys familiar with Daikin? You've done some Daikin, so you know that if you've got 20 indoor units and all of them are cooling and then one of them wants heating, what does the Daikin have to do? It's got to switch to heating mode outside. Even though only one unit's calling for heating. Otherwise you can't get heating. In the branch box is the magic box. Inside this thing is basically a system unto itself. This really does work slow. The big thing I have that nobody else has here, you can't see it very well under the lighting, but there is a gas liquid separator. I never have subcooled liquid leaving my outdoor unit, even when I'm in 100% cool. One unit inside wants heating. I have enough heat in that refrigerant to separate gas from the liquid and provide heating to one indoor head. It sounds strange that I could have 97-degree saturation temperature coming into that liquid separator and put 140-degree hot gas to an indoor head, but it will do. There's two tube heat exchangers inside. LEVs, linear expansion valves. You guys are pretty familiar with those? Any questions about linear expansion valves?
Do those ship all the way open? So like when these things are installed, you can evacuate them?
Yes. Yes. There's a part in here where we talk about adding a refrigerant charge to the system. While the power's off, once you power it up, all the valves close. So all the valves are open when it comes from the factory, before you powered it up. So the gas liquid separated tube-to-tube heat exchangers, to do the subcooling, we do it here when we need subcooling. The refrigerant flow is determined by check valves and a solenoid block. If we want heating, we will open a solenoid to allow hot gas to flow to a particular indoor head, and the check valves will keep it going in the correct direction. And if we want cooling, we open 2 other solenoids and allow liquid refrigerant to flow to that indoor head. So my expansion valve is either controlling superheat or it's controlling subcooling, depending on the mode that it's in, that particular indoor unit. Some of my ducted units are PEFY. You probably run into these. We've got our 6-ton and 8-ton models. We can do up to 8 tons with an air handler. My PCFY, ceiling hung cassette unit, hangs below the ceiling. This thing can throw air in cooling mode about 80 feet.
No.
What drives me nuts is when people put it in a server room and the wall's only 10 feet away. I got wall mount units, up to 30,000 BTUs. When it comes to installing these units, you guys install any wall mount units? Some? Tons? How many screws you put in that plate?
Just one.
As many as you can do. At least one. So you don't get in trouble?
No, I level it out.
There's about 40-something holes in that thing, so you should be able to find a stud, right? I don't know if any of the service guys have ever run into this, but I've gone to a unit trying to get it to the mini pump on the back side of it, and I go to pull it off the wall, and that's them holding it on my shoulder. There's 2 screws for holding that thing on, they weren't in a stud. That's irritating. Gravity draining is the best way to drain these things. Water runs downhill, don't ever get in its way. I've got these ceiling cassette units. We have some little bitty units that are 2 foot by 2 foot. Access to them is up on the side, electrical panel. The 3 foot by 3 foot ones I like the best because all you do is open the filter door and there's the electrical panel. It's all from below. If you guys are looking for the serial number on the little 2 by 2 one, the name tag is up on the electrical panel, but the serial number is behind the filter door. Guys will write down a number. I'm like, where'd you get that number? Oh, that was on the tag. That's not the serial. Go look under the filter. We got the one-way sealing cassette unit. We've got a floor mount unit. This one's designed on the right here to be exposed. The one on the left to be installed with ducting or some kind of ducting. I can't handle a lot of static. Don't run a duct 25 feet off that thing. And our air handler. Any of you guys installed one of these yet? Yeah. Anyone never see this yet?
That's a new one.
That's the new one.
Damaged one of his own.
That might be the best air handler that's ever been manufactured in my view. That thing's built like a tank. Most air handlers are shaped like a horseshoe with a panel in the front. That is 4 separate panels. If you have a small hole and your coil can come out of the unit and fit through the hole, so will the rest of the unit. Because it can be completely disassembled by 2 guys with a drill, stuck through a hole in the attic, put back together in 15 minutes.
It won't be looking the same.
What's that?
It won't be looking the same after all.
Well, I can't control that. They overbuilt this thing so sadly. Even around the plenum connection at the top, there's half-inch high-density foam insulation. The entire upper cabinet, 1-inch foam insulation, and the blower compartment is wrapped with bubble wrap, so you can pull the blower out and clean it easily. All the screws have a plastic backing on them so they won't rattle. And the screws for the blower door and the electrical cover door have spacers. You cannot over-tighten them and crush them. You pay about $1,100, $1,200 for one of those, but they're really well built.
Selling any of them?
We actually do.
And what's the biggest?
This is Washington State. You got homeowners here, oh, how much is that HVAC system? 38 grand? Okay, when can you start? Like, holy crap, I should go in business. We're going to pay that kind of money. We also have electric heat available for those units. It does not mount in the air handler, however. It is a separate component, a box 6 inches high. You have to allow for that. From 3 kW up to 17 kW. That's only been out about a year, by the way.
Pull that meter element out of that box after it's already installed on here, you just sort of.
You have to service the element. I've never had to service one.
Efficiency, I really need that.
Is it difficult? Servicing, I don't know. But you gotta pull it out. They never do that. That's what Mitsubishi told me.
So that unit, the static on it, it can,
Up to 0.8 inches.
okay.
You don't want to design around that. You want to design around the 0.5 for default, but it's capable of that. Upflow, downflow, horizontal, left, right, no special adapter needed. If you go to MyLinkDrive.com, how many of you guys ever been to MyLinkDrive.com, their website? Who's never been? You can actually find tech tip videos there, or even in the install section for that unit, videos showing you how to do it in different configurations. Mitsubishi has about 75 tech tip videos on MyLinkDrive.com. So you can go look at them. Explaining how to install certain components, how to take stuff apart, how to troubleshoot flash codes, what they mean. It's pretty cool. If you've never been there, you will not find printed material except for what you get with the unit when you buy it. You're not going to find a printed service manual. You can go to LinkDrive to find that. And a typical unit, city multi-unit, service manual is 450 plus pages long. Some of the thermostats, operation manuals, 75 pages long, just for a thermostat. Here's my hex unit. I have 3-ton and 6-ton hex units. Can tie to a city multi-piece of equipment, provide heating or cooling, chill water or hot water, up to 113 degrees. And there's a booster unit that has a compressor in it that will boost the water to 180 degrees, if you need it. It's basically a heat exchanger and some controls in the hex unit. It's only got four temp sensors, 2 for water, 2 for the refrigerant. But it works just like any other indoor unit. It has an expansion valve. You address it just like any other unit. Water flow, 5 to 9 GPM on the 3-ton and 8 to 18 GPM on the 6-ton. On LinkDrivecom is an app note about different piping configurations if you want to be specific with that. It's about 15 pages long that will show you different applications, whether it's preheating, direct heating, in-floor heating, snow removal, that kind of stuff. Controls. I've got the AE200. You guys seen this before, install one? Do you guys do the wiring, or does someone else do the wiring?
No, we do.
Do you do it yourself? You have in-house electrician? Okay. How many guys typically might touch an installation? Guy doing piping, different guy maybe doing metal, different guy doing controls,
Wire and fire.
different guy doing the drainage.
Yeah.
So it could be 4 or 5 separate entities on a typical install. Good coordination. So my touchscreen AE200 can control up to 50 indoor units. It can also be linked to 3 other central controllers, EW50 or the AE50, and control up to 200 units from this one touchscreen. Networking, it's IP. IP access, browser access. You can also access it with a PC. Some things you can get on the PC you can't get on the touchscreen. The A200 can do on-off, set temp, band speed, typical stuff you might see in a central controller. External signal for emergency stop. We really don't recommend, it does not recommend that be used for life safety, like a fire shutdown. We'd rather you kill power to the unit. We can't guarantee that that will stop the equipment if there is a fire. Here's how you wire a smart ME, my smart ME stat, and that was not supposed to pop up right away. So a smart ME, you guys install any of those?
Is that touchscreen?
It is a touchscreen. I'm guessing no. There's no secret, it's in the book.
It's in some installers.
My link drive.
Yeah, it's on my link drive. There's a back door which I can't tell you anymore. So this thermostat has an occupancy sensor. It is addressable. We call it smart because it does not wire directly to the air handler, it wires to the MNet, communication loop. You have to address it to the unit you want to control, like this one here. Address to 01 for unit 01. Address to 02, that one is in a group with another unit, so it is controlling 02 and 03. You have to be careful if you have a mix of these thermostats and the simple MA type thermostats. Because if this thermostat looks up the address chain and does not see another NP, it takes over that unit. For instance, if unit 3 had a wired thermostat connected to it, this unit would control it. They fight each other. And if there was no more NEs and there were 40 units on there, that thermostat there would control all the other units down the line. So if you're going to have a mix of them, put them backwards in the addressing. Don't put them in the front of the addressing. That makes sense? To address this, you pull the front cover off and it's 2 rotary dials down there on the lower left side. X1, guess what digit that is? Ones. And X10 is the tens. You guys know how digits work, right? Because I have one piece of equipment that it doesn't say ones and tens. It says first digit and second digit. And I tell guys address it to 51 and I look at it and it says 15. When I write the 5, what first? Don't you write 5 first if you're writing 51? That's not the first digit. The 1 is the first digit. happens so often, it's crazy. And I get in an argument with one guy 7 times about first digit and second digit, what that means. So I came up with a new addressing scheme for those pieces of equipment. We set the outdoor unit to 55. Can't get it backwards. There's my rotary switches. I just got that one set to 8. The 10 is still on 0. The 1s is on 8. The system will apply the 1 in front of that. It will actually show up on the maintenance tool as a 108. Here are my 2 MA type stats, the PAR 33, the newest version of the PAR 31.
What if you have 8?
What's that?
What if you have 08, not 108, 08?
Well, that's all you're going to address it to, 08. The system will give it the 100.
Oh. Well, what if you have 100?
You don't have a third digit. You could address it to 80, and guess what? That's not a thermostat address. That's been done. It will show up on a maintenance tool as 180, and it will not control anything because it will not know it is a thermostat at that point.
That won't get confusing with the air handler. On the air handler you have
ABC, that's for the port addressing. We're going to cover that too. That gets guys confused too. Sometimes they will use the address dials to set the port, and the port dials set the address.
Can the MA stats control 2 like
MA stats can control up to 2. So they wire to a different set of terminals. If you guys remember, or did you see, that this one does not tie to the thermostat terminals, it ties to the same connection for the MNet. It's on the MNet and communicating with the outdoor unit. In the MA type stats, in the MA stats, there is a dedicated set of terminals in the indoor unit, labeled 1 and 2. The connection you're going to tie them to is TB15. The MNet connection is TB5. This is a 12-volt output. If you make the mistake on that ME, which is MNet, so it's 25 to 30 volts DC, and you hook it up to these 2 terminals, it will have a display, and it looks like it's going to work, but it won't work anything. You go to turn something on, and it doesn't come on. But 12 volts is enough to turn on the display. A very common mistake.
Hang on a second. This is all a learning process. There you go.
So we have the PAR 33 and the simple MA, we call it, because it's very simple. All you can do is turn things on and off, change set point, no programming of any kind. You can control up to 2 indoor units with a wired MA stat. You wire the stat to 1 unit and daisy chain that TB15 to the other unit. You cannot control more than 2 units. Guys have done it, hooked them up. It doesn't work all the time. You get 3 units hooked up, it works about 50% of the time. You hook up 4 units, nothing works. It's only approved for up to 2 units. I've also got Kumo Cloud and the MHK1. Has anyone seen these before? Anyone heard of Kumo? Have you never heard of it? This is an app-based controller. It does not have a device except for the receiver that goes on the indoor unit. It's brand new, or I say brand new. It's been out there about a year and a half. Kumo Cloud.
the modular wire, that's the modular wire. He's got how to drive around and tap into that.
Here's one I have in my cabin. I can turn it on from right here. Give it set points, changes. I leave it set about 50 for freeze protection. I can turn it on before I leave the house. By the time I get there, it's usually at set point. But it's only based on the phone. It's app-based. There is nothing to go on the wall.
So mini split?
Mini split, city multi, anything that has a CN105 plug.
So if you have no service, you have no control of your unit.
No, this is Bluetooth when you're
Okay.
within range,
I'm good now.
but it can also connect through Wi-Fi. It's Wi-Fi or Bluetooth if you're in the range of 100 feet of the unit, basically. I like it personally for what I have it on because I can set up notifications, high and low temp. If I have it set 45 degrees, it notifies me if I have it turned off because I look at the weather and if it's going to be in the 50s, I don't turn it on. Only when it drops down in the low 40s and 30s do I even set it to 50. So I have it set to 45. If it gets 45 inside the cabin, it sends me a notification that it's 45. And then I have it set to 90. And if I get a notification that it's 90, the next call I make is to the fire department because it's never going to get 90 there. My AE200, it's touchscreen access or web browser access with a LAN connection. It can do trending, which I think is a cool thing. It came out with the EB50 when trending started in our central controllers. But I can take a particular piece of equipment, I can select thermal on time, show me the minutes of thermal operation, and average room temperature, which I use, two things I use most if I'm going to look at something. And I can do it by day, by month, or by year. And if the system is old enough, I can look back and see what it did 3 years ago. Or I can look back and see this year what it did on January the 2nd in that particular unit on that day. It can manage up to 3 other central controllers. It can also do tenant billing. To do tenant billing, you have to have 2 of these. You have to have one dedicated just for the pulse inputs from the watt meters, and the other one to control all the equipment. You can get personal web browser in a situation where maybe you have tenants and give each of them a unique access to that central controller remotely. That only they will go in and only see their unit and no one else's unit. Can also do BACnet over IP and again the tenant billing. It can also allow you to connect by a LAN connection using the maintenance tool software and look at all the operating data in the system. You need a switching Ethernet hub if you want to connect all those devices together. And every unit has to get its own unique IP. We also have the EW50, no touchscreen. Does everything the other one does without the touchscreen. Except it can't do tenant billing. It can do personal web browser, BACnet over IP, and allow you maintenance tool software access with a LAN connection. It wires to TV7 on the outdoor systems. So all the outdoor systems that have up to 50 indoor pieces of equipment total on them would be daisy chained across all the TV7s and then go to the central controller. Now, some common mistakes. Incorrect addressing. One of the most common mistakes is the port addressing. I have been involved in about 95 city multi-startup assists over the last 3 years, and I can count on this hand how many have not had port addresses wrong. Whether it was 8 units or 508 units, they've had misaddressed ports. Mnet wire should be 16-2 plenum wire, stranded and shielded. 18-8 thermostat wire does not work. Speaker wire does not work. 14 gauge Romex does not work. I've seen all of those on jobs. Refrigerant piping errors are another common mistake. Running the wrong size piping, crossing piping, or pitching it incorrectly when you're at the outdoor unit. Refrigerant leaks, another big one. Improper pressure testing or evacuation. We want these units pressure tested to 600 PSI. You guys do that already, right? On everything, right? You're hoping so? Doesn't some municipalities want to see the gauge showing 600 PSI? Like Seattle does, don't they?
Bobby just wants to see the low side.
The regulator doesn't go that high.
You gauge won't go that high?
525, that's not sufficient.
We want to see 600 because this unit might operate at that pressure.
Screwdriver.
Can you get him a new gauge? Improper condensate drainage. One of the biggest mistakes is connecting to the wrong drain. Some of our ducted units have a drain on both sides. And the one in the back is not primary drain, it's a secondary overflow. If you're using copper piping, now it gets, can be more expensive trying to repipe that sucker. Lack of nitrogen purging when you're brazing. Nobody brazes without nitrogen on a 410 system, right? Do they?
We got some fancy new regulators that, you guys have those with the purge setting? And Yeah.
Does it work well?
Makes it easier.
Not if you got a long run.
Not if you have a long run? Just keep the oxygen out of there. All you do is keep the oxygen out. Don't let any in there. Guess what happens to all that copper oxide after the unit starts up and starts running?
Filter dryer?
We don't have filter dryers. We have strainers. We have strainers, and believe me, they are a pain in the ass to get to, some of them. But all that copper oxide ends up in the strainer because the POE or PVE oil or whatever it may be in that system is a natural detergent, and it will clean the inside of that pipe. It already contains 16 ppm of acid. So any service guys want to do an acid test kit on an R410 system has to use a 410 acid test kit, or they could get a false positive with a mineral oil test kit.
So on that last one, what is the correct port addressing?
Whatever port you connect it to.
Is there any tricks to that, or it's just?
Follow your piping. I'm going to show you a few visual aid tricks as we get towards the end of this, if you guys are installing. You guys ever use anything like a visual aid? Do you know what that is?
Piping diagram?
Well, it could be a piping diagram, but it's just a Sharpie sometimes. For instance, I take port 1 from my BC and I ran it to FCU14, for instance. And on the BC, under that port, I should have FCU14 written there. Not only that, I should have the address of FCU14 on there. And not only that, it should tell me how many feet that piping ran. This is all information you might need to gather.
We'll mark those places on his fault. Nobody knows where the air handler is. I narrowed it down to the branch, I valved it off, got the rest of the system online.
There's an air handler, you don't know where it is?
We don't know where the air handler is.
I found it.
It's behind sheetrock.
Well, it's all individual suites and stuff, but it's all pipes and hardwood, you can't chase it.
See, that's the hard part. If it gets buried behind a hardwood, I've got guys that call me, they got a leak in the system. It's lost its refrigerant. They find the leak, they fix it, but they don't know how much refrigerant goes in the system. Nobody ever wrote that down in the unit. The only way to figure that out is to measure all the piping. And the guy up at Whatcom Community College in Bellingham, it took him 3 months to map his piping. He had no air conditioning for 3 months. So I need to know all the piping links and all the model numbers of all the equipment you have. And our diamond system builder will do all that for me. But I need all that information. If you don't have it written down anywhere, and just taking a Sharpie and spending 1 second making a note can save you days down the road. Like that ME stat I showed you. You guys remember the ME stat, the one with the occupancy sensor on it? When you take that one out of the box, it is covered with shrink wrap plastic. And you're going to typically leave it on there because the construction site is dirty, right? I take my Sharpie out and I write on the front of it whatever address I need to address it to on the plastic. Not permanent because when I pull the plastic off, it's gone, but I can walk through the building, look at a thermostat, and know what address it is just by walking up. The other option is to go up to it and pop the cover off and look and see what it is. If you're looking for one particular thermostat in a building with 50, that could take a little while. But if you have something marked down so you can see it just walking by, that's how fast does that take to see it? Any other questions about some of these common mistakes? I'm going to end up showing you some here in some slideshow. When you get ready to install this equipment, select the right location, maintain clearances. What is the clearance from the front of the unit to an obstruction by code? Like 3 feet for 230 volt and 4 feet for 480 volt. 4 feet, a lot, yeah. Usually on a roof, that's not usually a problem. Make sure it's level. If it's not level, it might not drain properly, right? If you hang a wall mount unit with that wall plate on a wall that's not flat, it's not going to last a whole long time. You start tweaking those wall hung units because the wall's not flat, maybe it's curved in some way, and you put a stress on the bearing on the end of that blower and it's going to wear out in months, not weeks, depending on how bad it is. I walked through one building and I look at the wall mount unit and the louvers are jammed up on the left hand side and there's an inch gap on the right hand side because the unit's like on the plaster wall. It's got to be on a flat wall. And you got to have screws across the bottom of that plate. When I did it, 3 at the top, 2 in the middle, 3 at the bottom is minimum what I would put in there. Because if it's loose on the bottom, it rattles. Use the template if there is a template. And make sure that whatever you mount it on can actually support that thing. Fresh air. If you bring fresh air to any of my units, it must be filtered. And a lot of them, it must be fan powered. And do not bring in more than 20% of that unit's rated CFM. Make sure you have the static pressure settings correct. And you guys have a T&B crew, so they're probably going to be setting that. And any dip switches that need to be set. We're going to cover some of these dip switches a little bit and what they do. And this is something that the project manager should have a conversation with the end user or someone, the engineer, to decide where these things are going to be set. Because ideally, you only want to touch that unit one time. Not have to keep repeatedly going back to that unit to make a change to it. If you're going to be standing in front of the unit, you should address it, the port address if you know where it's going, any dip switch settings that need to be set, record the model and serial number, make any marks on there you should make. I'm going to show you a screenshot of a visual aid that I've got a contractor doing down in Pendleton, Oregon right now, and it is saving them a ton of troubleshooting time when we run into something on startup and we got a problem with wiring or power, or we're missing units that don't show up. Clearances on the outdoor equipment. There are several pages of this in the manual. I would refer you to make sure you read the manual. Piping installation. You will find the pipe sizes listed in the submittal for a particular piece of outdoor equipment. You guys ever twin a unit? So you'll find the pipe sizes listed down here in the submittal for any twinned piece of equipment. It's one of the things when I do a startup I look at to see that the pipe sizes are correct. And the twinning kit is installed in the correct unit. The twinning kit should go in the larger of a twin system if they're different sizes. If they're the same size, then it doesn't matter which unit they go in. But if I got a 96 and a 120 tied together, then it should go in the 120. The liquid line twin kit, this is the one that has the most mistakes in it. And it's my favorite thing to run into because guess what I get to tell you?
Pipe it.
Yeah, if you go to the install manual, it's going to show you this screen. It's going to show you the liquid line twin kit where it comes together. It's a Y fitting. And it's going to tell you you need 19 and 11/16 straight piping after it twins together It's 500 millimeters of straight pipe before you put a fitting. And that twinned Y needs to be horizontal. No more than 15 degrees off horizontal, just like the diagonal. If I see it at 45 degrees in vertical, again, I get to tell you to, would you please repipe this? That thing's got 180 pounds of refrigerant in it. And don't take a crowbar and go, I saw a guy doing that one day. I got it pretty close. I'm like, there's a big old kink in that line. Can you repipe, please? I don't want to start this unit up. 500 millimeters, just 20 inches or more. If I walk out on the job and I see it at 18, I'll stay quiet about that. But if I see it at 14 or 13, I'm going to repipe it. Make sure that it is horizontal, not off horizontal more than 15 degrees.
Why did it have to go in a riser?
What?
What if you have to put one of those Ys in a riser?
In a riser? Don't put it in a riser. It's got to go horizontal.
You gotta put a T in there then and run two Y?
LG can do it.
Yeah.
LG can do it. This is an LG computer.
It's got to be horizontal. It's got to have 20 inches of straight pipe here. Over here, there could be a 90 right off the fitting. A straight 90. I don't have any requirements on the other end where it splits. But where it goes together, going towards the branch controller, I need 20 inches of straight pipe horizontal. So if you're setting units on the roof and you already know where the roof penetration is going to be, or you don't yet, plan that out so that you have the piping and you don't have to do this, because I looked at it and said, only way I can see you making this work is go out there a few feet, turn around, come back. You didn't think this out very far. Did you read the manual? What manual? The one that came in the unit. And I look in the unit, it's still in there. Can't open the pages anymore because it's been in there for 3 months and it's soaking wet.
The 20 bucks on the phone.
Maybe. I suggest that to Mitsubishi, right? This is a vertical twin kit. Been running 4 months. I asked them to repipe that. 5 months. Here's a system that had 14 outdoor twin units. 5 of them already had refrigerant charge put in them, and I asked him to repipe it. And of course he wasn't happy, and he screamed at me, "Where the hell is that in the book?" And he pulled out the soaking wet one. I went, "It's right here, like a page 11. Steve, right here."
Is that?
Failure to read anything. That's going to get repiped. I need 20 inches of straight pipe there. It's the first thing I look at when I walk on the roof.
Is there water underneath that roof?
Is there water under it?
Membrane?
Digging those penetrations.
No, it's not actually touching the roof. It's about 6 inches off.
Why is the 20 inches required?
Yeah, why do you need 20 inches?
Why do I need 20 inches? So that I have uniform refrigerant flow after that twin kit. If not, I could end up with an imbalance of refrigerant in the outdoor units.
So that's what it is. It has nothing to do with noise or anything else.
It's all about balancing the refrigerant between twin systems. Yeah. And it's critical enough that it can kill a compressor over time. Yeah, 14 systems, 5 were charged with over 100 pounds of refrigerant each, and it's rainy season. I had to make him repipe all of these. He hates me to this day. Here's one where I don't have 20 inches after the twin kit. It's only about 3. This is one, here's the wall where it penetrates. The only way to make this work was now go, turn around, and go in the house, in the building.
So is there engineering where you can upsize the pipe? It just seems weird to put that many 90s and U-turns to make it better.
Do not upsize the pipe, ever.
I'm just wondering if there was some other, seems like that would be a better way to mix it.
A better way to do this would have been to know this beforehand, actually read the book, and then set the units
That situation.
a few feet over there, because there was room to do that.
Yeah.
But again, it comes from not being familiar with the equipment, and it's as simple as you guys taking the install manual and just thumbing through the first 10 or 15 pages. Probably 20 minutes of doing that, and you won't have any of these problems. It's that simple. But most guys, I've done this a million times, never had a problem before. It can be a problem, and it is a problem, and we would want it fixed. And as a tech support guy representing Mitsubishi, one of the things I have to do, unfortunately, often is show up on job sites and say, whoop, I know that's not why I'm here, but until you fix that, I can't help you. If you obviously install something incorrectly, I put my hand up and say, call me when you get this fixed, and then we'll address the other problem. Because this could be causing the problem. There's another view of the twin kit, high pressure line, low pressure line, gas twin kit, the suction line twin kit needs to go into bigger of the units if there is a bigger unit. Another view of the twin kit in the bigger unit. And then internal view of that gas twin kit. So the two suction lines are going, one suction line is going to come in, and we're going to tie the other suction line to the other unit. But we're going to tie both suction lines into one unit in this twin kit. And you have the option to go out the bottom of this with the twin piping, or come out the front of the unit with the piping.
Is there any requirements for length of piping on that one, or it just has to be inside the larger of the two?
You have to keep those units within 6 feet of each other. There is a limit to how far they can be spaced.
But as far as the piping and the twinning right here inside the larger of the two, you don't need 20
It's a
inches?
kit.
Okay.
You're not gonna cut the kit. It's made to fit just like this so that the pipes will line up with
Okay.
the exit in front of the unit. And then you put the cover door on.
Okay.
So put this on here too, guys, before you braze the rest of the piping in.
No, the question is, that's a Y right there, and Mitsubishi don't require 20 inches.
This is
No,
a
it's
gas
just
line.
a kit.
Oh, I saw
This
it.
is a suction line. This is not carrying liquid.
Okay,
Suction line only.
go to Saxo.
Don't pitch it from one unit to the other unit. It needs to pitch towards the BC if there's any pitch at all. One guy read the book recently on a job that I was on, and he read that you're not supposed to pitch it more than 6 inches. So he thought the units had to be pitched 6 inches. So he built one unit up higher than the other unit so he could pitch it 6 inches. He just failed to really understand the book or read it properly. I just like to see it level. Level's fine. Pitching towards the back unit, not good. It'd be an oil trap. And this is a proper T orientation for refrigerant flow. You guys are an old established company. I would imagine none of you are doing this. That is what's called a bullheaded T, if you didn't know, and that will affect refrigerant flow. One of these, if there were 2 units there, one will work and the other one will not work. It is amazing how this affects systems like that, but it does. And the worst case situation here is if that's installed in a system, and usually it's in one of our Y series that doesn't have the branch box, because you're running one line and T and off going to all the indoor equipment. And wherever that T ends up, all the equipment from the T back to the outdoor unit all work great, and everything past the T doesn't work. And if it's buried somewhere where you never find it, you'll never know what's causing their problems. But I've got data on the maintenance tool that shows its effect. This was a job in Lacey at a grow-op. There were 48 of these systems, units, in the building. He'd already spent 2 weeks building all these T's.
That was good.
I went to do a job walk because another thing that I'll do for contractors as they're installing the job, I'll make a periodic visit if they want, and I'll look for mistakes before they become big mistakes and where you can still fix them. And he was still piping the indoor equipment when I saw this. I said, man, you gotta repipe all those T's. Why? Well, they're all bullheaded. And what's a bullhead? Never heard of it. Well, this T up here at the top is correct for refrigerant flow, but that bullhead is not. I said, why didn't you just use the header? Because we make a header that can have up to 8 lines coming off of it. And he says, what header? So I showed him a picture on LinkDrive what the header looks like, and he calls his boss and said, why didn't we use a header on this damn job? And he said, because it cost $85. You don't realize it's gonna take me 2 weeks to fix all this? With all the fittings and brazing and nitrogen and all that stuff? We would have saved a ton of money. And it was just worked, it would have worked perfect, because for every outdoor unit was 8 indoor units. 1 header, 8 lines going to the 8 indoor units. Again, this is something I'd say, hey, can you repipe that? Even if it's been running for 6 months. Otherwise, I'm obligated to go to Mitsubishi's website and make a note in that model, in that serial number of that unit. So if anybody ever looks it up, they'll say, oh, it's got bolt-headed T's on the job. Warranty, Sorry.
So either liquid line or suction line, no
Either
bullheads.
one, do not bullhead that T. Our big wall mount units, I say big, anything over like 12,000 BTUs on city multi-side, has 2 gas pipe temp sensors because that coil is split into 2 coils on that wall head. So there's 1 liquid pipe sensor, or saturation depending on mode, right after the LED, but then there's 2 on the exit of the gas piping. Hot gas and heating, or lit suction gas and food. And there's a company that has a server room for Amazon down here by Lake Union, and 2 server rooms, each with 4 pieces of equipment, 4 indoor units, with the wall hung units. 3 on one system work fine, the last one does not work. And on the other system, 1 unit works fine, the other 3 do not work. They don't have more than a 5-degree temp split. And when I looked at the maintenance tool data, those 2 gas temp sensors should read pretty close to the same temperature. They're both the suction line. But in this case, 1 unit on one system, 1 temp reading was 50 degrees, the other one was 75. How can I have different suction temperatures out of the same coil? And on the other system, 3 of them look like that. 45 to 50 degrees, and on the other one, 70 degrees plus. And I asked them, you got any bullheaded T's? Because that's all I could think might cause this. To that point, which was about 6 months ago, I had never seen data from a bullheaded system. It's usually been caught before it happened. And he went looking through the building and called me later that afternoon and said, yep, the first T on this system is bullheaded and the last one on that system is bullheaded. And it just verified what the data was showing. So it will cause a problem. Okay. You guys are already doing this. Insulate these pipes separately, and they should be insulated. Or they will condensate and drip water in cooling mode. And do not run them both in the same insulation, or you will turn that piping into a heat exchanger. Pressure test it to 600 psi. We'd like to see that hold for 1 day. And evacuate, triple evacuation, and have that hold for at least 30 minutes. In fact, your pressure test and evacuation details have to go in the DSB that's submitted to Mitsubishi if you want extended warranty. You guys aware of the extended warranty? No. Our standard warranty in a city multi is 1-year parts, 7-year compressor. If you fulfill these requirements, and it's really easy to do because you're already doing it anyway, a completed diamond system builder file, completely filled out with all models, serial numbers, line links, elbows, elevations in the equipment, all that kind of stuff, and a project properties tab that has information like this for extended warranty. That, 60 minutes of run data from the equipment, and a system information file captured with maintenance tool, only takes a second to do that. Submitted with this DSB, and your warranty is now 10 years of parts and compressor. And we have a new program. I don't know if you guys have signed up for that, but Mitsubishi will give you 2-year labor warranty if you're signed up into that program, provided all this is approved. This has to be approved first. They'll pay you if you have a problem the first 2 years. So this is easy to do, and it amazes me that some guys don't do it. And one of the biggest reasons why they don't get this, they haven't sent anyone through the 3-day course, and that's a requirement. Somebody has to go through that course in this company. You guys have had a bunch of people do that. So that having this submitted for extended warranty is easy. You got it for the job at Polyclinic. Whether you wanted it or not. Triple evacuation, you guys do a triple evacuation? Of course. Of course, every time. Don't have to teach you nothing about that. Diamond System Builder, if you're using the Diamond System Builder, it will calculate the charge for you. How are you doing that now?
Links a pipe, chart.
So you're doing what's in the install manual by hand?
Yep, no,
How you doing that?
Send it to Casey. Casey puts it in the computer, and then he tells you what to put in there.
Okay, so he's using the program.
Yes.
That's good, because it's easy to do. It doesn't take very long at all. Usually there's a Diamond System Builder file where this system was designed. All you have to do is put the information in it. Here's what the Diamond System Builder file would look like, building a tree of equipment, putting in all the line links, and getting a charge amount.
Yeah. Going back to the piping, can we use Zoom lock on it?
Yeah.
Okay.
Yeah. You've used it before?
We've used RefLock.
Not even close.
Yeah.
You use some reflock on jobs?
Yeah,
While they were still in
ours
business?
held, Hermanson didn't.
You were at Hermanson?
No, we were been downtown fixing one of their piping jobs.
Which one?
I don't remember the building.
Joe, Arnold,
I don't know,
Walton?
do not know.
And so I did a bunch of startups for Daikin when Hermanson did those jobs with reflock. I saw all those leaks.
Yeah.
I asked them what they were gonna do about the expansion of the pipe with some of these Y joints, and they, what do you mean? He said, well, that thing's gonna do like this all day long. And pretty soon, yeah, you come back 3 months later, it's oil dripping out of those things. Yeah, that was a mess. That was a mess. Zoom lock is backed up by Parker.
Yeah.
You got big pockets to fix anything. In fact, on some jobs when Zoom lock was first being used, when it first came out here, there were some problems. The contractor not doing the proper steps and cleaning the pipe, deburring and all that. They sent an engineer from St. Louis out here. He took samples back to the factory. He cut them open. He wrote a big long report showing photographs and how someone tried to brace those things together when they were leaking. All burned up, O-ring melted. Yeah, but if you clean the pipe and there's no scratches in it, you deburr it properly. There's a job here in Des Moines Hotel. They saved 500 man-hours piping the outdoor equipment using Zoom lock, and they have had no leaks in 2 years. I like the product. There's my outdoor charge added. And you have a digital record of it in case you don't write it down in the unit. Somebody has that. And now, actually, the DSP is in the cloud. It doesn't reside on computers anymore unless you save it to a file. It's all in the cloud and it's accessible all the time. Nobody can lose it. It's on Mitsubishi server. LinkDrivecom. Some guys have never been here, right?
maybe, I don't remember.
Everything you want to know is here. Service manuals, engineering guides, submittals, software, controls. All that stuff is on here. Like I say, they only print the install manual op guide that comes with a piece of equipment. There's enough information on this website to keep you reading for the rest of your life. You can download this entire thing called PC, Link Drive for PC, and it resides on my laptop, so I don't have to have internet to access it. It's 8+ gigabytes long, took 2 hours to download. And it updates every time I connect to the internet. There's new stuff, I get the updates automatically. So the service guys might want to have that PC. If they're remotely out somewhere and don't have internet, it's still available. You can also figure out the charge on these equipment going to MyLinkDrive.com and getting the additional refrigerant charge calculation tool if you don't have the DSP. This is basically just an Excel spreadsheet to do the math for you. So you got either option. You can download that spreadsheet and just have that and not need internet connection. Or you can go to the install guide like this and do it all by hand. And I know guys that do this, calculating all this stuff out, spending 30, 40, 50 minutes trying to calculate the charge when the DSP would do it for you in about 10 seconds. And the Excel spreadsheet maybe in 3 minutes. And then people invariably make a mistake with this because they're not good at math. They haven't done any since the 4th grade. When they got to the 10th grade, they said, I'm never going to need that crap anymore. You guys ever do this? This is a trick they actually taught me at the Daikin school. Yeah, use your recovery machine. Pull it out of the tank, put it in the unit. I can do about 3 pounds a minute that way. I don't have to have power on the unit when I'm doing this. I can get all the charge in there before power's ever turned on. We didn't trust at air reps, we didn't trust the contractors to do this correctly, so I did all the charging before those units were started up, just to make sure it was done right, and that's how I did it. I teach guys this trick and they're like, you know how much time that's going to save me?
You gotta have a clean machine though, don't you?
You gotta have a clean machine, be careful there, don't just have pulled all the charge out of burnout, turn around without cleaning that thing. Yeah, but you pull it out of a system, put it in a tank, you can pull it out of the tank, put it back in the system. And you gotta put 120 pounds in a system, you're gonna get maybe 25 or 30 in by vacuum. And then you gotta charge the rest while it's running, low charge. It could take an hour metering it in there.
You charge too much, it goes down to a minimum.
Yeah. Hope it keeps running while you're trying to do that, you're 100 pounds low. Yeah, you can get it all in there with the recovery machine before you turn anything on inside, because all the LEDs are wide open. It's easy to do. At least I think it's easy to do. Let's talk about condensate piping. Anybody have any questions about any of the piping part? Reefer piping? No. Everybody went to sleep 2 hours ago. You already know this. Either I tell them, friends, either I'm doing a good job, or nobody understands my language. So use 1-inch PVC for drain lines. That's Mitsubishi's recommendation. What size do you guys run? 1.25 inches? 3/4. I think it's Snohomish County that looks in the manual and it says 1.25 inch drain connection, and that's what they want run. And what Mitsubishi meant there was an inch, it's got an 1.25 inch outlet fitting, but they want a 3/4 fitting go in it as your actual drain line. But Snohomish is kind of, dry and black and white. Why didn't you say that if that's what you meant, kind of a thing? Provide a pitch as usual and keep your horizontal rate less than 65 feet. Do not install traps or air vents. None of our units require a P-trap. I know that polyclinic job, I had to ask them to take 3 of those 4 units and repipe them because they had P-traps in them. And they were piped to the wrong side of the unit. Do not exceed pump up limits. On our ducted units and on our ceiling cassettes, they have a lift mechanism. It's a little pump inside the unit. And it's designed to lift you up high enough to find gravity drain. It is not intended to go through a roof 10 feet over your head. There is a lift limit for that pump, depending on the unit you're going to be working on. And it is either from the ceiling or the bottom of the unit where that starts, not where the drain opening is. Does that make sense?
It must have looked like they're about, 6 inches?
No, well, 6 inches from the unit away might be the limit, or 12 inches from the unit away before you go up. That's the limit between the B. But the A could be anywhere from 19 to 33 inches, depending on the unit you're working on. And again, anybody want to ask that question?
Why?
It'll backfeed, just go right back into the unit, it goes on, off, on, off, on, off.
We'll go back in the unit because there's no check valve in that pump. And the reason there's a limit is that is how much the drain pan can hold if it goes back in the unit. If you ran that thing 4 feet up, then you're gonna overflow the drain pan when it runs back in the unit. And the pump that's in there, I have never yet seen one fail. They run continuously. If you have it in cool mode, never has to see a drop of water. Cool mode or dry mode, the pump turns on. Change mode, turns off. Unit satisfies temperature, keeps on running. As long as you have it in cool or dry mode, the pump runs. Now if you gravity drain any of those units, we want you to disconnect the pump. And make sure you seal that outlet on the upper side of that. Here's the gravity connection, the lift pump connection. See the little hanger up here? Got little tits that point down? Like my poor deceased aunt, hers always pointed down too. Those should point to the ground. If they're pointing to the sky, you have it upside down. It gets installed upside down because they see the drain outlet and they think, oh, that's the bottom of the unit. And of course the float trips as soon as you turn the power on, it's tripped and it gives you a drain alarm error. I just turned the unit on and the drain's tripped on. Float's telling me I got a drain error. I don't have any water in the unit. Can you read the nameplate to me? Well, yeah, but I gotta turn my head upside down. You can't put the cover plate on that electrical panel upside down. It only goes on one way, so if the lettering is upside down, so is the unit. This call actually comes in about every 2 weeks at tech support. Where one of these units is upside down.
You guys gotta put a bottom, this is the bottom.
We need an arrow pointing up, up. On the back side of some units is another outlet. If you look carefully, you will see that this one on this side is near the bottom pan of the panel, and the one on the other side is about 5/8 of an inch higher up on the unit, because it is the emergency overflow drain line. And guys mistakenly connect to that often. Sometimes because, well, it was closer to the drain. I didn't have to go under or around the unit to get there. And make sure you unplug the drain pump if you do gravity drain it. Here is a picture of a unit piped from back here when the drain connection is over here. There were 16 out of 18 units on this job that had to be repiped, all in copper. The drain pump plugs into the CNP plug on the indoor unit. It is labeled CNP, connector for pump. One thing Mitsubishi is really good about is what they name their connectors. Pump for pump, CN4F for float, connector for float. It's almost impossible to miswire a unit if you change a board, because if it's the same color connector, it's a different size, and if it's the same size, it's a different color. If you see a red plug in a green socket, it's not supposed to be there. Wall mount units, no P-traps if you're gravity draining that. And if you're not gravity draining, trying to get into a condensate pump, no P-traps. We have other built-in safeties if you have an auxiliary drain pan under a unit and you want to shut a unit down. Many of the connectors for the float safety also have a little jumper on them, the CN4F. You can cut that jumper and tie an auxiliary switch into that as a secondary means of shutting down that unit.
That's a big service call, you installer guys, for us. When the condensate pump fails, those cheesy ones we put in, we get a COM fail error, because that safety on those always gets tied into the COM and not that plug. A lot of misdiagnosis unless the guy knows to look for it. I see it on everybody's jobs, ours and the competitors. So please do that.
Are you talking about like city mounted or the little mini splits?
The mini splits. I can't tell you how many of those I get. It's a COM error call. It's always that to get condensate pump. They just hacked into the third wire instead of using that plug.
If they install an Aspen mini white pump on it, it tells you any install instructions for that pump to cut the S3 wire.
Yeah.
Yeah,
It tells you,
yeah, but that's not what the unit says, that's what the pump says.
The pump, the install for the pump says that, but also in very fine print, somewhere along the margin, if you turn it sideways with a magnifying glass, you can read it says, refer to website for specific manufacturer wiring instructions.
So how are you supposed to wire that in?
S1, you break. S1 and S1 only, because that's only carrying current.
but it won't come back on.
It will come back on in a mini split if you break S1 and you reapply S1, the unit will come right back on where it was before.
Put it on that condensate thing, plug. Forget cutting any of those lines.
Or you can just break S1, if you got a mini split.
Yeah,
How are
but
you
then
gonna
you
break
don't
the
get
power?
the code for condensate alarm when your condensate is on. You'll still get some other erroneous error.
You can't get a code for condensate pump
Yes,
station.
you can on a mini split.
Not on the wall mount units. On some of the other units you can. There's another input. You can use a CN4 input.
Yeah, that's
what he's
that
talking
plug you were just talking, that's
Yeah.
where
The
I
wall
like
mounts
these
don't
guys.
have that plug. The little small wall mounts don't even have, they don't have a way for you to, if you want to kill a little 6,000, they don't have the CN4 plug. The P-Series do, the M-Series don't. P-Series units.
I'm positive on that wall, on that ceiling mount.
City
one.
multi-units do,
No, these are.
except
these are
the 6,000
Single
BTU.
zone, single zone units, I'm positive that ceiling mounts, I just didn't want to.
Ceiling mount does have.
And,
Ceiling mount.
I'm sure the others do.
Wall mount M-Series does not have a needs to do that. It's always breaking S1.
Oh, the channel compressor.
Electric power installation. You guys do the power or do you control?
Just control.
Just control? When you guys get ready to start this unit, the big thing to me is get power on the outdoor unit the day before you plan to turn the system on. I want the compressor hot. I want it warmed up. And we're doing that by trickle charging through the winding of the compressor. Why do I want it hot?
Sure. All the gases out.
I want all the liquid out of that thing.
Liquids out.
If you actually read the install manual, they want you to meg ohm the compressor before you apply power to it. And if you're reading 1 meg or less, heat the compressor up because it could be liquid in the winding. In fact, the first thing that happens when you power my unit up, the inverter puts a little bit of voltage real quick to the winding of the compressor to see if there is a short to ground. And if it is, you get an error right away. All of my, even the little mini splits, they do that. As soon as you turn on power or you tell the unit to run, little bump of power to the winding, and if it sees an amp draw through the current transformers, if they're not running, got to ground somewhere. And liquid refrigerant can cause that. You guys know what a flooded start is? Liquid is saturated in the oil, and sometimes there's so much that it actually is, the oil is floating on a layer of liquid. Who's played a joke on their buddy where they took the beer bottle in? Waited for the foam to settle and handed it to him. You ever do that? I know one guy has, come on, raise your hand. Maybe when you were 17, right? I couldn't drink when I was 17. As soon as you pop the top on that, what happens? Somebody gets showered with beer, right? Same thing happens in the compressor. As soon as you turn it on, you create a pressure differential, and any liquid refrigerant comes out of solution, turns the oil to foam. I don't have any data to tell me how long you will drain the oil out of my compressor in this inverter-driven system, but I know in a hard start 60 Hertz system, it only takes 3 seconds to drain every ounce of oil out of the compressor on a flooded start. The very first time we turn this unit on is when most mechanical damage happens. If that compressor has any liquid in it and we wash out the oil, we are going to wear the bearings the first 10 minutes of operation. It can be the difference between a system that lasts 2 years and one that lasts 25. So I like to see power on this unit the day before. And when I hook up my maintenance tool, I can tell if it has been on. I see the discharge temp is elevated versus ambient temperature. My ambient temperature is 50 degrees and my discharge temp is 68. I know that compressor has been heated up. When I see them both the same, I don't want to run the unit. I'll try to reschedule another visit back. We'll leave it on all day, come back tomorrow and try to run it today. If you plan ahead before startup, get the power on beforehand. If you're worried about something running because you're not fully ready yet, just keep the power off to the branch controller. If that thing has no power, nothing can run. Get power onto the outdoor unit as soon as you can. Even before you've opened the ball valves or added the additional refrigerant charge. Get it powered up. Just keep the power off at the BC. Install the control wiring at least 2 inches away from any power wires. Do not route it with power wires. You're going to induce noise on the line. And we're going to have COM errors. The infamous 6607 error that pops up every hour and you can't get it to go away. There are about 10 pages in the service manual dealing with that error code and all the things that can cause it. Wire nuts routed across a fluorescent light, all those kind of things can cause COM errors. Make sure the outdoor unit's grounded, and again, do not put splices in the MNet wire. If you misran a piece of wire to the wrong place and you're going to splice it and make up the difference, you're going to get 6607 error codes. You want home runs there from terminal to terminal. Leave a service loop at the indoor unit is good practice. You guys know what that is? Just an extra foot or so of pipe of wire outside, so in case you nick something, you got extra to pull in there. I've seen guys that had to pull a new wire from the branch controller all the way to the outdoor unit because it was nicked and shorting on the cabinet of the unit, and there was no extra wire to pull in. It was tight as could be. Only use 16 gauge 2 conductor stranded and shielded, and again, no splicing of that wire with wire nuts. If you have to make a splice, solder it together. And that still is not a guarantee you're not going to have problems. Give the terminal connections the tug test and make sure you can see some copper sticking out from that terminal. You'd be surprised how many guys stick the jacket under the screw when they tighten it down. If you can see copper sticking out, good. Tug on it. Doesn't come out? Good. I tug on the wire and it comes out. Well, here's where your error code is. Now I found the first unit like this, go check the other 200 because they're probably all the same way. If you see one like that, you got to assume they're all like that. Got to be this type of wire, and where can you find that, you think? The type of wire you should be using?
Gensco.
Yeah, we sell it. Just call Gensco, we have it. Find that, the specific information in the install manual. TB3, TB7, M1, M2 shield. Connect the shield to the S terminal. Do not ground it to the unit at the outdoor unit if you have a central controller. If you do not have a central controller, ground it at the outdoor unit. It does not come, that shield terminal in the outdoor unit does not come grounded at the outdoor unit because it will be grounded at the central controller. It is internal to the central controller. And we only want to ground at one place in the shield. If you have a ground in 2 places, you turn that interlocking pipe wiring into an antenna. And now you are picking up the weather channel. The ME controller wires to TB5, the MA controller to TB15. The BC controller is labeled TB02. You go from outdoor unit to BC controller and then each indoor unit successfully in a daisy chain. Do not hit the BC and then branch off in a star pattern to 28 different units. You will have problems. Even if it works most of the time, it will not work all of the time. Here's an example of the wiring through a typical system. TB3 on the outdoor unit to TB2 on the branch controller, and then hit all the TB5s of all the indoor equipment in line. Any ME type controllers go to TB5, and any simple MAs or wired thermostats go to TB15. If you're looking at this, what I went over earlier, when I mentioned about the addressing of ME stats, could I address unit number, that first unit in line there as address 1? Or would I make it address 5?
Make it 5. Go backwards.
Make it 5 and go backwards. Who was paying attention? Remember I said if you have an ME stat in line, and it does not see another ME stat in it with a higher address, it takes over that unit. So if I have an MA stat, and in this case, like this, the 2 ME stats, I have to address those first 2 units, 1 and 2. I can't address them 4 and 5, or the ME stats will take them over and control them. It's a common mistake. It usually doesn't show up until weeks or months after the job was started, when whoever moves in starts complaining, and my unit just got a mind of its own. It's doing something. I got it set to heating, and it went to cooling all by itself, because the guy next door is setting his to cooling, and he's controlling that unit. And you asked about the secret code.
Yeah, when you got to the thermostat after that, that's the one I wrote back to know about. I was looking at the thermostat. I don't have those.
So these ME stats have 2 access codes for different functions. If you want to lock the screen, the access code is 4 zeros by default, and you can change that. The service access is 4 nines, and you can even change that. And there's a backdoor access I'm not going to tell you, in case I ever have to get in it after you've changed it and lost the access code. And they don't give out the backdoor access code anymore because this thermostat has a fatal flaw. If this is installed in a condo situation or a hotel type situation, and someone has intimate knowledge of how these things work, I can go into that ME stat and take over every other unit in the building. Give them all the command of heating at 85 degrees, and then disassociate that stat from every other unit in the building, and no one will ever know where that came from. If I got a neighbor in my condo and I don't like him, he is going to burn up every night when I figure out what unit is his. So they stopped giving out the backdoor access code because it would get you past any access code that someone may have set up in that thermostat. Yeah, that's a fatal flaw, I call it. There's a hotel, the same one that did all the June log piping, that someone went in one of the hotel rooms and wrote on a thermostat, had a display on the thermostat, praise Allah jihad. Because you can go in the thermostat and give it a room name or whatever. You can name this thermostat, hey, this is the thermostat for room 624. They wrote in its place, praise Allah jihad. They had to know how to do that. It wasn't just some random customer. It's a guy who's familiar with Mitsubishi. Well, the hotel freaked out. They thought they were being hacked from outside the building, called the FBI. And this kept recurring. Every few months this was popping up, and I kept trying to convince, I could not convince the facility manager that that is one of your employees, or that is a guest who has knowledge of Mitsubishi. But I keep changing the password. I said, because he probably knows the backdoor password. That is not someone hacking you from outside. You can't do that to the thermostat without standing in front of it. It can't be done remotely.
What was the fix?
What was the fix?
Yeah.
I said, try to find it. I actually talked to the guy and he did.
High end.
I had a guy admit, yeah, we stayed in that hotel, a whole bunch of us. He was laughing. I said, okay, I know where it came from. But I'm not going to rat about it. I think it's the hotel that just needs to do a better job managing that. Or change the thermostat. They tried, they kept moving the thermostat around, but it was the same unit. Happened twice in it. I said, it is not being hacked and it is not on a schedule to suddenly show up every June. We're getting the same guest coming in here, or he's in another room with a friend who's in this room, and they're playing a joke on you. So be aware of that. If you run into that after the fact, that weird things are happening to the thermostat, it can do weird things. And the flaw is that I can attach, I can go into group settings and set every other group in that building to that stat, give it a set point, and then unset them from that stat. They're trying to get away from doing that in hotels now, using that stat. Do not cross-wire the TV3s between systems. You're gonna get a lot of error codes out of that. But that is common when lines are crisscrossing through the same floor. Oh, I tied that unit into this one and that unit onto the other system. If I do that, if I crisscross this somehow, let's say I get these two units tied to that MNet and these two tied to that MNet. When this unit turns on, it's going to turn on that outdoor unit, but no indoor units may be calling for refrigerant. So that unit's going to start running and nothing's opening up for the refrigerant to go anywhere. It's usually found on startup when you're testing it. But it's easy to do if you have multiple systems in one little area of a building or on a floor. This is the BC. The terminal TBO1 is for power, and the MNet goes to TBO2. Again, leave a service loop there. And you have to power all of our indoor equipment with 208, 230 volts. If you power the BC with 110 volts, nothing's going to work. If you power the indoor unit with 110 volts, it will work. And it will run at half speed for years. I say that because I went on a job 6 months ago. It was a house with a Pumi, 8 indoor units. 4 of them, after 2 years, the fans quit running. And when we got there, we found the electrician had wired it with 110 volts instead of 220. We couldn't easily fix it by just putting in a double pole breaker because he also hit wall outputs as he went down the line. The electrician was out of business. It took that guy 8 months to get an electrician to come in and rewire that house. And it cost him thousands of dollars personally because it was custom millwork that had to be cut throughout wiring. It was just terrible. But it's amazing, those units ran for 2 years and they worked. Nobody ever complained. Inverters are magic. You don't care what they put in them, it'll put out 3-phase AC. MNet transmission does have some limits. I have to keep one system from TB3 on the outdoor unit. I can't go more than 656 feet with my MNet. There is a limit. If you exceed that limit, there is no fix for that. You cannot fix units that have too long wiring without shortening the wiring in some way. My total wiring between, say, 2 indoor systems that are daisy-chained on TV7 that have a central controller, from farthest indoor through the outdoor and down through another indoor 1,654 feet, 40 feet, and from central controller to farthest indoor unit on any one of those systems, 1,640 feet is the wiring limit. I don't know anyone that's exceeded that limit, but the 656 limit has been exceeded quite a few times. Here's my piping limit from the farthest indoor unit, and by the way, in ME stat is a unit because it gets an address. So wherever you put this unit and this thermostat, that's included in that wire footage. From thermostat through outdoor system to farthest thermostat, if it's an ME, 1,640 feet. From here to here, 654 feet. From central controller, 656 from thermostat if it's an ME to outdoor unit is limit. This gets too many times. Guys run this and exceed that limit because they don't read the manual. I had a job in Yakima I went to start up. They came within about 20 feet of exceeding that limit in a building 100 feet long. He'd never been through training. He thought, based on his DSB CAD printout, Unit 1, Address 1 was where he had to run the wire to first because it shows it in that order. outdoor unit, BC, and then by address. So he followed that to the letter. Unit 1 to Unit 2 to Unit 3 to Unit 4, so forth, and then all of the Losnay controllers, the ERVs, were at the back end. Then he hit all the ERVs. Even though these units were sometimes side by side, had addresses, 5 addresses apart, the wire had to go through other units and then come back, and then go back to other units. He followed it by address. But you do not have to do that. You take the shortest route possible. You can hit address 37 first, and address 1 last in the wiring. Find the shortest route. Yeah, there's also a limit on how many pieces of equipment you can hook up to an MNet. Because each piece of equipment that gets addressed draws power from the MNet, and there's a power limit. The power limit is a total of 32. If your power totals equal 32 or more, you need a transmission booster. And the transmission booster has to go directly in the middle of the MNet. If you exceed 40 pieces of addressed equipment, you need a transmission booster. The transmission booster helps with the power drain. It does not help you with long wire. Let that sink in a little bit. Some of these jobs start off with MA stats, no power drain. They're powered by the indoor unit. And somewhere near the beginning of the install, someone decided in engineering or of the end user, hey, I want this thermostat. And many jobs have started out okay, and they install it, but somewhere along the line, they decided to put the MEs in, and it put them over the power limit. And nobody caught that. And they have nothing but COM errors. Unit shutdowns, endlessly. My outdoor unit connections, TB3 is on the left and TB7 is on the right. Try not to cross those up. Does that make sense? TB3 for indoor. TB7 goes to central controller. And I believe it even says it under there. Central controller for central controller. That's the one that's going on the wall of the touchscreen. Wonder if I'm getting weak here. There's a PUMI. If you ever do any of my PUMI City multi, they also have TB3 and TB7. A common mistake here, because some of these don't get a central control, is they hook to the wrong side. Be aware of where they go. Remember the job I just mentioned in Yakima? Not only did they exceed the wiring, almost exceed the wiring length limitations, this was a wood truss attic where all this equipment was installed, and they used this kind of staple on the MNet wires. There was only 14 indoor units on here and 3 Losnays. It should have taken 4 hours to complete a startup. This took 3 days. It took 2 days to rewire the building. There were 37 shorts in this wire due to this staple. Anybody have any questions about the wiring? None? What? Have I scared you enough already? Addressing is real simple. Any indoor piece of equipment should be addressed somewhere between 1 and 50. That's an indoor unit. Outdoor unit, the range is 51 to 100. Those are the main things you're going to address, that and the BC. The outdoor unit should get an address exactly 50 higher than the lowest indoor unit. So if I had a lowest indoor unit on a particular system address at 11, what would I address my outdoor unit to? Some guys can do math. Thank you. How about if I had the lowest unit 34? 84. Does that make sense? Now you can mix it up. I've seen them mixed up and it still works, but it is ugly. And it's service guy's worst nightmare because it's hard to identify what goes with. I would like to see the system, what I call clean, where all the addressing is perfect, because it makes troubleshooting easy. Like this. Lowest units 1, 2, and 3 is connected to that BC. And this I'm showing you a sub-BC. Have you guys ever installed one with a sub-BC? This is the one where you cannot, at this point, screw up the addressing. This has to be perfect, or it doesn't work right. 1, 2, and 3 are on BC number 1. My outdoor unit's going to get 51 because the lowest unit is 1, right? My BC follows my outdoor unit, 52. If I have a sub-BC, whatever the lowest unit is hooked to it, it has to be 50 higher. And that unit's 4, that BC gets addressed to 54. If I only had 1 unit on that first BC, I can't use unit 2 because my BC is 52. If I address that one, if I have another unit over here addressed at 2, it's going to open ports 2 in that other BC. If my addressing isn't perfect like this with sub-BC, I could open the wrong BC's port when I ask for a unit to run. So 1, 2, and 3 here, and then 4 and 5, that BC gets 54, 50 higher than the lowest unit on the sub-BC. And you could potentially have a system with 2 sub-BCs. This is an example of what I call clean addressing. First system has 6 units, address 1 through 6, outdoor units 51, BC's 52. My second system, indoor equipment, is addressed 7 through 11. My outdoor unit, the first unit, the OC, is going to get 50 higher than that, 57. Then I follow that with the subunit, 58, and the BC gets 59. Does that make sense? If the entire system is done this way, and there could be 4 or 5 systems with up to 50 indoor units on one central controller, I cannot have any duplicate addresses going on. A problem for you guys, not because of you guys, but engineering might be working on a design, and they come up with a perfectly addressed system. And as this proposal system goes along, which could take months, oh, we want to change these 2 units, or we want to change that unit, we're going to change this unit and change that unit. And every time they go on the DSP and make changes, those new units get new addresses added. And by the time they finish and output that CAD diagram with all the addressing, you got a system with address 1, 2, 37, 38, 48. Because all the changes made. If it's coming out of our central quoting engineering department in Kirkland, they go in and fix all that stuff. So they print out perfect diagrams. But if it comes out of Tacoma, it isn't fixed like that. And a lot of the contractors' engineering, it isn't fixed when it finally gets out to you guys. But you do not have to adhere to what they have designed. You can go in and alter this and make it perfect as you install it. You can look at it and say, yeah, this is ugly. I'm going to readdress these units this way. Make changes on the printout yourself. And do it like this. Addressing the unit is done by rotary dials. Who's never seen my rotary dials? Everyone has seen a rotary dial? Are they easy to get backwards? Addressing is one of the most common mistakes because they'll do the 10s or 1s digit backwards. If I address an indoor unit at 84 instead of 48, it doesn't know it's an indoor unit. If I address an outdoor unit at 23 instead of 73 because I mistook what the book said or somebody wrote it wrong, it doesn't know it's an outdoor unit. Here's my outdoor unit address dials. Can you guys see that? Can you see what it's addressed to? I don't know if that's any better. Tens digit, it's a 5. Ones digit is a 6. So the dials go counterclockwise, there's bigger numbers. That dial, if you've never seen one, is kind of a smoky color with a cutout. And the cutout is where you set the address. And that ME stat on the wall, they're very hard to see because it are all white. And if you, sometimes these things get turned to an address but aren't actually there. They turned it and it says 5, but it never really got there. So when you set one of these addresses, take the dial and just wiggle it a little bit after you set it there. Make sure it made contact on the 5. Or this might show up as a 6 instead of 56. Here's my BC address. It's rotary dial again, just like the outdoor unit or the indoor unit. Now here's my indoor unit. I'm going to have 3 dials. 2 for addressing. 1 on the left is for porting. SW11, SW12, and SW14. It's easy to tell which one is for the ports because the port address dial has letters. You can have up to 16 ports. So once they get past number 9, it's A, B, C, D, and E. And if you're going to have a 16 port box and set it to address 16, go all the way around the dial back to 0. That'll be 16. It makes sense? This had a guy who did a job with 250 units. 7 central controllers. Did every unit exactly the same address. So I had duplicate addresses on 3 or 4 systems per central controller. He had to go back and readdress the entire building by himself. Took a month getting access and all the problems doing that, and get it done right. And I'm going to show you a printout a little later of the CAD printout of what they typically give you to go by. And I asked him, where's your printout? He says, well, I don't have one. So I went to our Kirkland office where we have a big plotter, and I'm printing him out blueprint size addressing scheme for all the equipment in the building. And as I'm on the way back, I finally get a call from his project manager. He says, oh, I have that. Why didn't you give it to your guy? He's on the job doing the work, not you. Well, he went from this job where he had to readdress the whole job twice to the next job that only had 14 units on it. And he set the ports with the dials on the right and the address with the dial on the left. Completely got brain freeze after that first fiasco. Why am I not switching?
I think it's break time. It's that thing that looks frozen. I don't know what's going on.
No, don't lie. What's up?
You made it.
I made it.
You guys want a quick bathroom break?
Sure. That model is a wall carpet, and that has the CN.
PUZ. Yeah, the P series do. None of the M series have it. And the city multi little bitty wall mount units don't have
I
it.
take this all.
Turned off before.
Turning them
And then
both
one
on
of them
simultaneously.
simultaneously serves a completely different function.
Sensing from the remote controller, SW1-1, the one you're probably
going to be turning on most of the time. The fan settings typically are not changed. Default settings usually are adequate for that.
But if you need to turn the fans off when it satisfies in heating,
which ones are you going to do?
SW1-7 and 1-8. Turn on, satisfies heating set point, will stop the fan.
some people ask for that after the job's been running and they realize that city multi-unit fans run all the time when you have it turned on. They never shut off.
This switch on the indoor unit, this is SW1, it's gonna be real close to the address dials. Some of the units, this is a separate board. The address board, the internet board
With this dip switch, the rest of the dip switches are on a different board.
Here's SW3, if you turn on number 1 with the out 6 and out 7 and 8 on
SW1,
turn that
unit into cooling only. Which you may do if this is in a server room and you don't want heat.
Leave the other ones where they are and turn this one on. Switch number 3-8, every unit has a 4-degree Celsius overshooting heat mode built in. Because typically these units are installed up high, and it's going to be a lot warmer up there in the ceiling than it is down here where you're sitting. So to compensate for that, there is a 7.2 degree Fahrenheit heating overshoot built in. Turn on 3-8
to turn that off.
That
makes sense. Don't mess with any of these other switches. Some of these settings don't apply to every unit. And in some units, turning on one of these switches that's not supposed to be on does swirly things. And the one-way throw ceiling cassette up to 12,000 BTUs, I think it is SW3-6 stops the fan from running, and then the 15,000 unit, it gives a false drain error.
Here's setting fan speeds. All
This is going to be found in the install manual or the service manual.
Once you guys install it,
You're not going to deal with these two, but if you need to, that's where you're going to find this information.
Changing the power voltage, there's going to be a
switch in there, 220 or 208.
Wherever you have power
in that unit is where you should set that.
If you have it set to the wrong voltage,
It has no effect on the unit working, but it does affect the fan curve. CFM might be different if you're on the wrong voltage set.
Here are some other differences for setting static pressure.
The TAB guys are typically going to be doing that.
You have a central controller. Outdoor unit
It needs to be turned on in the master unit or the OC.
The
Twin system, the attributes are going to be OC for the unit that's the lowest address, or the biggest should also be the lowest address, and it will supply internet hub. The other unit's going to be the OS, it's a sub, but it's not a true sub, because those units are alternate, we lag every time they satisfy the home.
Then SW4-7 in the YLNUA for high
heating performance.
Is there any way to force that lead lag for maintenance?
For maintenance tool, yes.
Otherwise,
The maintenance tool and all that stuff.
it's in the optional settings part, forced operation. And the last
which unit you want to be lead.
And then the YKM unit, you have to set the high
heating performance by setting a function setting. This probably sounds alien to you guys, because probably no one's ever done that, but in the service manual is a list of different function settings that can be set in the outdoor unit. And a service guide, which I'm going to be showing them next week.
One thing you don't want to do is set function
921, so the temperature shows up on the display in Fahrenheit, not Celsius, and you don't have to keep the conversion.
The function 935 down here for high heating capacity. What
This is going to do,
it's not going
going
to
to
give
give
it
it
more
more
heat,
heating,
but it's going to let you do heating at a higher ambient temperature,
which in our climate typically can be a problem if you don't set this up. Even if it's 70 outside, somebody in that building wants heating. Without setting this, it may not heat above 68 degrees outside temperature. By setting the dip switches on SW1, the outdoor unit while 6-10 is on.
So here's SW6. Normally, all these switches are off. Here's SW4.
These are the dip switches that are used to look at operating data while the unit's running.
SW5 set mode
of the unit, physical size, BTU capacity,
or S75-1, you can see in the red there is turned on because the system has a central controller. It lets the outdoor unit know that the central controller is going to be making some command decisions. If you don't have that on, the outdoor unit doesn't know you have a central controller, and it may override the central controller for certain demand decisions.
But by turning on SW6-10 and then setting the dip switch combinations for whatever function you want to set, then press the little red button. There's no explanation on the board what it does. This is what it does. Once you set a function number, the function number shows up on the display.
That's 921. I was setting that in the training 2 weeks ago.
Hold the button down for 2 seconds, and then the upward light lights up.
You know the function has been set. Now, at this point, you let go and you turn off all the switches that you turned on, and the function is set. That's what you can do for the high heating setting. And usually that CAD display will print out from the DSP to turn on that function. Typically, that's what it says to do.
Be careful with any dip switches on the output unit on SW5. Those come preset from the factory except for 5-1.
And if you carry one of those accidentally, you might not run.
Those
tell it what size unit it is and what kind of unit it is.
And the only place you can find where it should be set
is in the service manual. In the back end of the troubleshooting specific error code that's going to pop up when you set that. It's the only place to find where they should be.
There's no listing on the panel, no listing in the install manual of where that says. It just says set it back. So context support, or remember what I just said,
to the back into the service manual. Ground gauge 398.
Project management. For any of you guys that may have a hand in this. This is the CAD printout you get from AutoCAD that shows the piping sizes, and
address scheme that's been set up in the Diamond System Builder.
Outdoor 5152, BC 53, address 1 through 6. It also shows that I've got NA type status tied to
TB15. That's how it was designed.
My TB7 wiring coming down to my central controller.
And the terminals that it connects to.
All this can be put out and into AutoCAD from the DSP. This is a close-up of that printout showing pipe sizes 4, 5 correspond to a specific pipe size, 7/8 and 1/8. It's hard to cross pipe my unit here
unless you're doing a P192 or 216 unit, because both lines are 1/8. And you've only seen it one time, and that was very recently. In 3 years of doing this, somebody crossed those two lines. You don't find it out until after you start it up. So using some visual aids, like marking stuff, you go, take gas line, liquid line kind of thing.
The other thing about piping, the piping comes into
the BC. There's two. If it's a BC main, that could have a BC sub attached to it, and in certain size systems, you have to use a main. You can't use a single. There's 2 pipes on one side to go to the outdoor unit, 3 pipes on the other side to go to the sub BC. People have piped it to the wrong side of the BC. And then if it is in cooling mode or heating mode, it's hard to find. It shows up readily in cooling mode, but not so readily in heating mode.
Here's a close-up of the addressing scheme and the wiring connecting to each terminal block. Here's my thermostat, TV5 for my unit. Here's an example of using a visual aid. I've actually printed this out on a box on here. But I've got guys that will go under the port, right, remember what unit it goes to, what address that it is, and how long the footage is. This is all the information you need to build a DSP.
If this is all printed out on here, I can completely rebuild this system in the DSP in just a few minutes. Without having to go trace all this stuff down and measure piping.
Here's an example of what I've got a guy down in Pendleton doing right now on a pretty large project. I've already been there 2 weeks and not even started equipment up yet. He says, identifying the unit. He's identifying the address of the unit. He's identifying what port
that unit's connected to,
and how far the piping is,
just like he's doing on the BC.
He's also writing down your MNet. It comes from
FCU
FCU4 and it goes to
FCU21.
So if we have to troubleshoot wiring in some way, we know where it goes next. We don't have to start ruling things out one at a time. We know exactly what it goes. This only takes a few seconds to record all this stuff on the unit, but can save you a ton of headache later. Here's an Excel spreadsheet that I built to keep track of all the information on a specific system. What the tag is, what type of unit, the address, what port it went to, what group is set up in the central control, what kind of thermostat it has. If it's an what the address is, where it is, model, serial, line size, how long the line is, how many elbows, and the unit's elevation. All that information has to go into a
DSB for extended warranty purposes. I can send this to you.
The DSB also, in the extended warranty tab, at the bottom of that page, there is an export to Excel tab. It will take all the equipment that has been listed in there and export it into an Excel file. And it shows up like this. I then take it before I show up on the job, or if I'm doing a walkthrough or helping guys with the addressing, and I put it in this form in an Excel file. And I tell them, this is where you should be addressed. All the units should be set up just like this, and I show up on the job with this thing in a spiral binder. And I go through it, I do start up and check it off. You can see here I've already got the serial numbers for the outdoor units. They still have to go to the ones for the indoor units. I have the internet address in here for them. The groups, I how I'm going to set it up in the central controller. And over here on the port side, what I'm doing is start up, don't put anything in there until it's been tested.
Like go use the maintenance tool, go into the system and test each unit's port address and tell whether it's correct.
And then I
add it to the sheet to make sure.
So now I'm doing page one job, guys, doing the job, there's a
You guys can keep it updated.
I'm also doing 185. Yes.
Like a limit on this thing.
Standard warranty, 1-year, 7-year compressor, but all the DSB, system settings, system
information file, and the 60-minute run data is done with the maintenance tool, 10-year warranty.
You have to have the DSB designed by
someone who is certified to use the DSB or design system with the DSB. I'm sure you guys are.
The 60 minutes run data in test mode, heating or cooling, not and it has to be 60 minutes uninterrupted. One thing they just changed with the maintenance tool is now using the maintenance tool, I can prohibit all the thermostats from the maintenance tool. There's nothing worse than doing a city multi-startup and getting 56 minutes into the rundown and someone turns off the unit. You start over, unless you can get it turned on right away. There's only a 1 or 2 minute break in the data, Mitsubishi won't say anything, but if there's a 10-minute, they're going to want you to redo it. Or program the central controller, and you look at all the thermostats that way. But now with the maintenance tool, I can start off right away. As soon as I collect the grid, look at all the stats. I've been in a job that had non-English speaking painters who kept turning off thermostats. And I didn't have a central controller. The maintenance tool hadn't been upgraded to do that yet. I had to keep going after thermostat and lock them out physically, one at a time, as I ran into that problem. Instead of 1 hour rundown, it took me 6 hours to get that down. And I was so mad before I left the job, I had prohibited all the thermostats on that floor by the thermostat, that I set every all the set points to 85 and I left. Sounds mean, but I couldn't get it to stop doing it. Now, they still got upset with that because they were trying to paint and it was too hot for them. Oh, I have to run it in heat mode, it's winter. Can't run it in cooling when it's 30 degrees outside. It was getting too hot for them, so they kept turning the units off. Then they went around after I left and pulled the thermostats off the wall and cut the wires.
Stuff like that you're gonna run into if you're doing the startups on these. So many trades on the job. Electricians turn the power off all the time. And when you go find an electrician, he says, well, that's not my panel. Joe's panel, he went to lunch. Or he had to leave early, he would do it tomorrow. I'm scheduled somewhere else tomorrow, my next open day is in July. So to get the extended warranty, the as-built diamond system builder file, 60 minutes rundown, and the outdoor, the system information file captured with the maintenance tool, and it just looks like the grid screen. All that has to do, those two files get attached to the DSP and submitted through the cloud to Mitsubishi, and a warranty letter will typically come out in 3 or 4 days. It used to take 6 months, but since everything's gone in the cloud, when I send that off in the cloud, every area service manager in Mitsubishi can get it around the country, open it up, review it, and approve it or disapprove. When something's wrong, they kick it back and say, here's the serial number for the central controller. That is simple of a problem. You hold it up. What is the phone number of the job owner? I don't know. I haven't been in the building yet. I got 45 days to get that to me. After 45 days, you don't get extended. Here's the diamond system builder again. Picture that. Maintenance tool rundown, all in test. In this case, all heating. And you need 60 minutes to show up. You can't see it on the screen. But I got to get 60 minutes, and it has to be in ordinary mode. If you turn off power to unit and turn power back on, it's going to show up in initial mode. And if you just turn power on for the first time, it's going to stay in initial mode maybe for an hour. I typically test all the ports while it's in initial mode, and then when all that's done, it kicks into ordinary mode, and then I get my run. Here's the system information file. Anyone who's ever used the maintenance tool, this is what we call the grid screen. It also shows all the connection info down here. I can see my address of my units, what type they are. This AU is a hex unit, that will heat exchanger, water to air, refrigerant heat exchanger. And I know it's a 6-ton because they're using 2 ports. If you've got anything over 54,000 BTUs, then it's going to be the 72 or the 96. We don't have anything else. You have to connect that to 2 ports. Each port can handle 54,000 BTUs by itself. It also means I could pipe 3 12,000 BTU units to 1 port and they don't work as 1 unit. Like in a big room like this, I could have 2 sealing cassettes, one on each end of the room, work as 1 unit off 1 port, and get better air distribution than having 1 big unit. It shows me those port addresses, my unit addresses, the type of unit I have. Mitsubishi wants to look at this and make sure it lines up with the maintenance tool. They want to know that address 3 is port 5, because the maintenance tool is going to show me what it is, and the DSP better show that unit address to port 5. If it doesn't, it gets kicked back. Hey, I got 2 port addresses that don't match the maintenance tool. What are they? It might mean sending someone out to the job to double check that. Sometimes that's good. I'm reviewing a job that had 500 units in it. Finally finished the startup after 6 weeks on a Thursday. On Friday, I emailed the project manager and I said, there's 2 units on the 42nd floor. The BTU sizing doesn't match the DSB. Either you install the units to the wrong apartments, or the dip switch is set wrong on the indoor unit. Because one board in an indoor unit might control 4 different sizes units, and dip switches tell it what size it's in. It's not uncommon to have units come from the factory with the wrong dip switch settings. Bottom number says 15,000 BTU, but the maintenance tool says it's 24,000 BTU. What is it really? Because you look at model number 1 of the unit to see what it really is. So he said, I'll go Saturday and do that. We got to the building, the bottom drain had blown off riser stack going through the cooling tower on the 44th floor, and about 200 PSI of water took out sheetrock for 15 feet down the hallway. And $1 million elevator. That was expensive.
Once this gets extended, these two files get attached to the maintenance tool.
It is
It's
submitted through the
cloud.
cloud.
I get a submission ID, the date that it was approved, and sent back with the warranty number
Shows up in the cloud, the DSP.
All this type of information
Needs to go in this DSP.
Who
Who did the job?
Who
Went through the city multi-course?
Your
Your pressure test and evacuation details have to go on here.
Who installed it, who the owner is,
Who was the engineer? Everything with a red asterisk has to be filled out, or Mitsubishi kicks it back. If you forget to put an email in here, it comes back.
Thank you guys for enduring. It's hard, boring, but if you have any questions before you go
Anything that you can't answer, you can answer.
I'll put your phone number in there.
You want my phone number? That's my number. That is tech services.
And that's
your best choice. I'm doing this 4 times this week.
if I get in my truck and you send me a text or email, I'm not gonna get to that. Because if I get in my truck, I won't let me use the phone. That includes driving the area.
But if you call me, so feel free to call me if you have any questions.
I'm available.
The other one, what's the 253?
This is technical services down in Tacoma. This, we have 2 people.
8 hours a day. We used to have 3, but we just lost one of our top guys. We had to move to Michigan. That was a big loss because other than myself, no one else had control. I'm not gonna tell you guys for hiring because you probably make more money than a job. No, Josh is still there. He's never going. He's young, he could be here 40 years. If he's here 30 years, he'll put down $1 million. I've been worked at Gensco for 30 years, I have over $1 million in the world. Yeah. They take care of us.
All right, thanks, Rick. Don't forget to sign in. You didn't sign in. There's a sheet going around there somewhere. If you're interested, Rick's doing the service one next week. Service without a maintenance tool. So go in without a laptop, and steps you can take, diagnostic kind of triage. Yeah, 5 minutes. Turn the knife switch off, turn back on.